When you look up at the sun, you see a life-giving star, a constant, predictable source of light and warmth. For billions of years, our solar system has run like a perfectly tuned clock, each planet locked in its stable, familiar orbit. But that clock is ticking down. We're just living in a deceptively calm moment in cosmic history. The truth is, we are orbiting a ticking time bomb, and that predictable clockwork is destined to shatter into chaos and fire. This isn't a question of if, it's only a question of when. So let's take a journey through time on a terrifying timeline of our solar system's future, from short-term disasters to the final, inevitable apocalypse. Our first stops aren't billions of years away. They're threats that loom within a time frame we can actually comprehend. Reminders that space is not empty, and it is most certainly not friendly. First off, we live in a cosmic shooting gallery. Asteroid impacts are a fundamental part of our solar system's story. If you don't believe me, just look at the moon. Its scarred surface is a museum of ancient, violent collisions. While the era of non-stop bombardment is over, the risk never, ever drops to zero. An asteroid just a kilometer wide would be large enough to trigger a global catastrophe, not from the initial blast, but from the impact winter that would follow. Dust and debris thrown into the atmosphere would block out the sun, causing worldwide crop failures and mass starvation. And while we have programs to track the really big planet-killer asteroids, it's the ones we haven't found yet that keep planetary defense experts up at night. But we don't need a rock from deep space to cause devastation. Our own star is perfectly capable of doing it. The sun regularly spits out enormous bursts of energy and plasma called coronal mass ejections, or CMEs. Most of them miss us, just flying harmlessly off into space. But what happens if a truly massive one hits Earth head-on? It would be a civilization-ending event. A powerful CME could overwhelm our planet's magnetic field, frying power grids and causing continent-wide blackouts that could last for months or even years. Communication satellites would be toast, GPS would fail, and the internet would collapse. In our modern, connected world, the result would be total chaos. It's happened before, and it will absolutely happen again. Let's jump forward on our timeline, past the immediate threats, into the deep future, millions to tens of millions of years from now. On these timescales, a new, more subtle terror emerges: chaos. The solar system feels stable, right? That's just an illusion created by our short lifespans. Over millions of years, the tiny gravitational nudges that each planet exerts on every other planet start to add up in completely unpredictable ways. The planet's orbits are technically chaotic. This doesn't mean they'll suddenly fly off into space tomorrow, but it does mean that over vast stretches of time, we can't perfectly predict where they'll end up. Simulations show there's about a 1% chance that Mercury's orbit could become dangerously unstable. Gravitational tugs, mostly from Jupiter, could stretch its orbit out until it crosses the path of Venus. The result would be a game of cosmic billiards, potentially leading to a collision or even flinging Mercury out of the solar system entirely. And if that happens, the whole inner solar system is thrown into disarray. It's not just internal threats either. A passing star that strays too close to our solar system could disturb the Oort cloud, a vast icy shell of comets at the far edge of our system. This could send a deadly shower of comets hurtling toward us, triggering impacts that would make the one that wiped out the dinosaurs look like a firecracker. Now, we journey to a point so far in the future it's hard to wrap your head around, 1 billion years from now. At this stage, the apocalypse isn't sudden. It's a slow, creeping death, delivered by our own sun. You see, even while it's stable, the sun is slowly and relentlessly getting brighter. For every billion years that pass, its luminosity increases by about 10%. That might not sound like much, but the consequence is terrifying. That extra energy will be enough to trigger a runaway greenhouse effect on Earth. The rising temperature will cause the oceans to literally begin to boil away. All that water vapor, a potent greenhouse gas, will fill the atmosphere, trapping even more heat. The planet will become a global steam bath, and eventually this water will be stripped away by the solar wind and lost to space. Long before the sun itself dies, all complex life on Earth will be gone. Our world will become a dry, sterile rock, looking a lot more like modern-day Venus than the blue marble we know. Around 5 to 7 billion years from now, the real end begins. The sun will finally run out of hydrogen fuel in its core. The engine that powered our solar system for 10 billion years will sputter. Gravity will crush the core, causing it to heat up so much that it ignites the hydrogen in a shell around the core. This new furious burst of energy will cause the sun's outer layers to expand to a monstrous size. The sun will swell into a red giant more than 200 times its current size. It will become so large, it will simply swallow everything in its path. Mercury will be the first to go, vaporized in an instant. Venus will be next. Earth's fate hangs in the balance. Some models suggest our orbit might be pushed outward, but most predict it won't be enough. The Earth will be engulfed by the sun's expanding atmosphere. Our entire planet will be vaporized, its atoms scattered within a dying star. Every mountain, every canyon, every trace that we were ever here will be erased. And even if Earth miraculously survived being swallowed, it would be nothing but a scorched, molten cinder. But as the inner solar system is destroyed, a strange, new habitable zone will appear in the outer reaches. As the red giant sun blasts heat outward, the frozen moons of Jupiter and Saturn, like Europa and Titan, could finally melt. For a few 100 million years, these distant worlds might host vast liquid water oceans, a brief, final chance for life in our solar system. After its violent red giant phase, the sun will puff its outer layers away, creating a beautiful glowing cloud called a planetary nebula. At the center of this cosmic ghost will be all that remains of our star, a white dwarf. It will be a smoldering Earth-sized ember of carbon and oxygen, shining only with leftover heat, but producing no new energy of its own. The surviving outer planets, Jupiter, Saturn, Uranus, and Neptune, will continue to orbit this dead star, their paths now much wider and colder. The solar system will be a silent, dark, and frozen place. The white dwarf will slowly cool over trillions of years, eventually fading into a black dwarf, a cold, dead stellar corpse. Over even longer timescales, the pull of passing stars might strip the remaining planets away one by one until the sun's dead core is left all alone, drifting through the eternal darkness. The story of our solar system is one of terrifying violence and inevitable endings. From the random chaos of asteroid strikes to the unstoppable physics of a dying star, our home has a finite and destructive lifespan. Every moment of our existence, everything humanity has ever done, is happening in a fleetingly quiet interval in an unimaginably long and violent cosmic story. But there's a profound beauty in that terror. It shows us how impossibly precious our world is right now. We live in that perfect moment, on a perfect planet, orbiting a stable star. We are the winners of an extraordinary cosmic lottery. Understanding how it all ends isn't about being afraid. It's about appreciating the staggering beauty and fragility of the present. It's about recognizing that our time in the light is short, which makes it all the more brilliant. If you find the grand scale of the cosmos as fascinating as we do, subscribe for more journeys into the universe, and let us know in the comments, what part of this terrifying timeline blows your mind the most?